I'm Kyrylo. I work at TransferWise. I do the engineering and do the overlooking of our European region and our European customers. So as you can imagine, it's mostly engineering, more dev, less ops. And we're doing this together with Ed, that leads the taming of misbehaving computers at TransferWise. We've been around for 6 years. How many of you know what we do? All right, this makes stuff simple. So we're, first and foremost, an Estonian company, actually. We're famous for our Estonian founders, Kristo and Taavet. And we're famous for our evangelical customers that tell other people about our service. Currently, we're doing, we send money around the world. Currently, we're doing 1 billion in transfers per month, dollars. And saving our customers compared to using a traditional bank around $50 million per month. The way we do it is slightly different from what a typical organization does. This does translate into our engineering culture. First of all, we do practice weak code ownership, but every part in our code base is owned. And what is most important, any team can change any part of the code as long as the owning team doesn't have any problems with that. But the most important thing here is we do engineer for customer impact, which means every decision, technical or product related, should be argumented by how it affects the end customer. In fact, our engineers do get close to customers, take calls, answer emails, and make decisions both on qualitative and quantitative data. We introduced Kafka into our messaging platform as we went on with our modularization efforts for the last 2 years. But the problem is that some of our team services do need to be highly responsive, they need to be synchronous, and they need to scale really well. And since we're around for like 6 years already, this means when we started, awesome stuff like orchestration and a lot of stuff that actually happened in the platform world over the last 6 years didn't exist back then, or just only started to exist. And our platform team right now is 8 people strong, which doesn't sound much, but it actually grew like 3 times over the last 12 to 18 months, which is a lot. But they still have a huge backlog, way more than would make them happy, and us happy as well. So when an engineer wants to have a new service that is highly responsible, et cetera, how do we handle it? So first of all, our platform team is kind of the only centralized, in a way, team in our engineering, which means this is the only team that engineers do kind of have to talk to. And so engineer comes to infra and says, like, I want a production service. And they have a huge backlog, so he waits, and then waits some more, and asks again, waits some more, gets a service, and then he wants to change a config in production, which is terrible because he needs to wait some more. And this just needs to stop, just because there's too much chatter. We do not like to chat without a good reason for that. We wait too long, we stress everyone. And first and foremost, our customers suffer because our delivery time is just becoming worse and worse over time. That is why, obviously, we do need automatic allocation. We do need automatic provisioning, logging, monitoring, auditing, you name it, without engineers being involved. And as we started to approach that, so we didn't have this problem a lot because there were not so many services. The more services we built, the more problematics it brought us. And the code base is pretty big, so there are other things to do. So when we started to approach this, we started to think about the basics and decided that, service discovery can help us with actually managing our infrastructure. First of all, we did a little bit of research and Tex got into the details. Sure, everybody knows this. We needed to implement a registry, a mechanism to register, and a lookup mechanism. All of this is obviously governed by the CAP theorem, which means we needed to choose 2 of the 3, whether we want to be available, consistent, or partition tolerant. In our use case, we decided that we want to be partition tolerant because of a bunch of data centers. and we want to be highly available. But since we're sharing network addresses, this is what service discovery is about. Overall, we don't want to be consistent. Obviously, we started to do this to simplify our operations procedures, not to make them more complex. That is why, obviously, we wanted to introduce client-side discovery. We want to follow the self-registration pattern, and we wanted to do client-side load balancing. We started to look out, and there are a lot of amazing solutions around the market. Airbnb does an awesome one. Facebook has an awesome internal Zeus. Yeah, a lot of them. But the thing is that we're mostly a JVM-based stack, and we don't want to change that by a whole set of reasons. So we decided that Netflix OSS is the way to go for us. First of all, it's really good for AWS. It's really good for a JVM-based stack. It's battle-tested on tens of thousands of machines, still being battle-tested. So yeah, we just decided to give it a go. Started with a proof of concept. Obviously, we need to build a skateboard first before building an automobile. And obviously, all of us know how hard it is to get to adopt a new piece of stack across all teams and especially across all services that are managed by dozens of different teams. So our goal was to make our monolith, which is still in place, to consume one service in production. To give you a little bit of context, yeah, we do have a Grails-based monolith, and the Grails version is like 5 years old. So we cannot adopt a lot of new cool stuff. But Grails is built on Spring, right? We do use Spring Boot a lot. We love Spring Cloud that has a lot of Netflix Eureka-related, already built-in stuff. So we decided to give it a go. Obviously, yeah, this is how we thought it should look like. And to understand the scope, we had one big problem, which means that, yeah, making friends between Spring Cloud and anything else except Spring Boot can be very, very tricky. There is no good adoption mechanism. And to be honest, the guys that build Spring Cloud stuff, well, there's a reason why it works only with Spring Boot really well and nothing else. So the solution was pretty simple. Grails and Spring are close, so we read the source and find out what hides beyond the awesome Spring Boot's Netflix-specific annotations. So to adopt this, we build a discovery client in our service, which essentially replaces what Spring Cloud does. Because in essence, what Spring Cloud does with the Eureka client that you can find on GitHub is creating a centralized set of beans in the application context. So we decided to do something similar. Obviously, each service that is being consumed by the monolith needs a client-side load balancer, so we create one. Most of our communication historically was done through the REST template. But what is cool that, yeah, the load balanced annotation is kind of built on top of the REST template. What it does under the hood is it takes the service name and it switches down the URI, which is pretty simple. So we do that as well through an interceptor. And what do we do if stuff completely fails? We do need a fallback mechanism. So what we started to do within a proof of concept, all right, we have DNSs in place. This is what we're kind of running from, but let's leave them. And if we fail, and we measure how much do we fail so we can see and evaluate whether we need to do something about it in the future. Is that it's a perfect solution? Obviously not. Actually, it sounds a little bit like a retarded brother of what Spring Cloud does. It needs maintenance. It is tied to REST templates. It needs engineers to actually think about it. I mean, engineers that are trying to adopt it. So it's not good enough. So the way to go was to start building clients to every service, which is kind of an obvious idea, and then make everything work as a black box. Like adopting engineers shouldn't, or yeah, consumers shouldn't think about that. But there are a couple of problems with the Netflix stack and Eureka client in particular that actually are not so obvious. So first of all, if your service wants to be discovered, you need to make your client to provide the toolset, which in essence means having a separate Eureka client that would communicate and make sure that the network map is up to date and your service is discoverable. And there are a couple of problems that hide underneath. Some services do have a Eureka client on their own. Eureka in itself is not used to it because configurations are stored in one centralized context bean, which results in overrides unless being controlled, which can bring you a bunch of headache and pain over time. Testing it is very problematic because it requires a full copy of production. Well, you imagine, hundreds of engineers need to have a full copy of a multi-service. Production is painful, and testing the pieces is completely on the adopting engineer. There are a couple of challenges besides that that we're kind of trying to mitigate. Just because we run in independent teams, the teams are kind of free in the technology and in the nuances of stuff that they implement. That means that it brings variation, I would say lack of standard, to HTTP communications and different implementations. Some teams use Feign as a client builder. Some use direct fallbacks. Some use Hystrix for circuit breaking for their services. Some split balancing and discovery between different services. And what is the most big problematic thing is that 75% of all problems that come from that are regarding solution compatibility, which means making Spring Boot, Eureka, Ribbon, Rails, everything work together, because it changes a lot. Nobody actually maintains the dependency tree that well, so there's a lot of problems and a lot of backwards incompatibilities that are very important for us. To give you a little bit of stats, we've been running it 3 months already. We have around 30 services so far adopted. 20 more are in the making. Yeah, so that's pretty much it. I hope I am on time. And now Ed can tell you about the fun stuff.
I think I'll use this mic here. Great. Lots of new services for me and the rest of the platform team to keep track of. Lots of config in there. Every service needs its own config. So in the classic way of the info team, let's make everything as boring as possible. Don't want anything interesting here. It's just config. So everyone here knows Puppet, Chef, Salt, Ansible, I'm sure. If you're not using one of these tools, sort it out. Just do it. Ignore the rest of the talk. Go home now. It's going to make your life so much better. Everything else I'm going to say is irrelevant. Just do this. You'll have 10 times the return. Job done. End the talk. Yeah, it kind of doesn't work that well for us as these autonomous teams. It makes certain things quite awkward, particularly as lots of services, lots of ownership teams, each team has their own config in their own repository, or we have a single monolith repository of all these secrets, which really in all cases makes secret management hard. And that actually turned out to be the biggest challenge for us, was how do we manage secrets between services? We can make it work with, well, we happen to use Ansible, just Puppet and the same. We can make it work, but actually it was just going to be painful and would be a constant source of just friction. So we thought, well, let's have a look and see what else is out there. So Spring Cloud, Netflix, HashiCorp Vault, all these things look like they could solve our problems for us. And we did a very detailed analysis and chose Spring Cloud because we use Spring other stuff. And that was pretty much the entire reasoning. We had a look at Netflix, RKS. It seemed to just make life more complicated for us for not really much benefit. And HashiCorp Vault looks cool, but we didn't really look into it that much because we have Spring Cloud already. And also Spring Cloud has really nice documentation. If you go on that page, probably any questions will be answered by that simple URL. It's surprisingly good high level and then detailed documentation, which I personally really appreciated. So how does this config server work? Very simply, it's name value pairs, and it has an encryption and a decryption endpoint on the server. So you can decrypt secrets by making a simple HTTP request. You can also likewise encrypt data via a simple HTTP request. And it's, as we mentioned earlier, really easy to embed in your existing Spring applications. It's also a really simple REST API, so you don't need to be writing stuff in your Spring Boot. For simple guys like me writing Python, it also works really well here. Everyone else, all the various different autonomous teams who might not be using the same technologies, it's very standard, it's very simple to interact with. Also, it actually supports templates and files. So the same way as Puppet, for example, or Chef use templates with variables within them to dynamically generate config files, we happen to not use them. They look quite useful. They look like they could work. We haven't had a use for them ourselves, but thought I'd throw that out there. So here's how it works. Very simply. Service queries Eureka, as we've just discovered, to find out the location of our config server. Simple response back. We then can query the config server to say, what config do I need? What config have you got available for me? Simple JSON response comes back. All the config server is doing is it caches a local copy of our config repo, which is stored on GitHub, and it just polls off there to see if there's any latest data, latest config. Secrets don't, I'm going to iterate this again because this is the most important thing for us. There's a reason we chose it, was secrets don't need to be stored in plain text because we have these encrypt and decrypt endpoints. A developer can, if he needs to add a secret, for example, database credentials or something like that, can simply decrypt them and store those in a cipher format in the code repo directly. Everyone can view that without having to worry about leaking the secrets. It becomes very simple and really nice. You can also use a Vault backend. Vault's been mentioned a couple of times already this evening. Simply requires a token from the client. The other thing that's quite interesting to consider, which is for your use case, is when you make a request, do you want to fail fast and just immediately on the start of your service, if you can't connect to the config server, just fail straight away? Something's gone wrong, let's just die, not worth trying it, or sit there and retry. We did this, it all worked, so we had to get into production then. We just grabbed a few service owners and said, you're going to be going to the new config server. And actually, when they realized it would require less time chatting to me, they were quite up for it. That was a big benefit to them. And then something shocking happened. It just worked. It literally took, I think, a couple of days for the first several services to be configured and to be put into production. It was very simple. We were, as I said, very suspicious. It's still running now. It's not been perfect. We have found a few issues, but it's worked really well. The most irritating one is when GitHub goes down, the config server keeps on polling. Just keeps sitting there making request after request after request. We think we find this, I'm going to tune this out with a few timeouts and variables, but we all know GitHub goes down at times. Config server doesn't like this. So we're actually probably going to move our config repo to an internal Git repo just to avoid that whole issue. May or may not be the solution. Also, it's kind of sensible, but that is a direct consequence of the config server is always caching the local config, but every time the request comes into the config, it also queries the remote repo. So if there are any kind of network issues, for example, GitHub down, it's always going to be a very slow startup time. So if you have a 60-second timeout on that request, you've got 60 seconds until that config can be returned because it's trying to check if the config is still valid, which isn't great, but it works quite fine. In practice, that's not a big issue. However, sometimes it does just die. It looks like it's sitting there doing, for example, this garbage collection. This hasn't been an issue for us. It hasn't caused outage. We've never had more than one node go down. But it makes me uneasy, and it probably makes you guys not want to use it now. I'm recommending it as something that is really good, but with this caveat that we don't know why, so you could be hit worse by this. We're still having a look at this and seeing what's going on, but I thought I couldn't really mention this as something useful or good without actually mentioning that it had not been perfect. But it genuinely has had this result, and things are getting to production much more quickly. Kyrylo will attest to this. The amount of time now taken to get stuff through, Infra and the platform team is becoming a lot less of a blocker, which is what I want to do. I hate blocking people. I'm not there to make people's lives more difficult. So if you also don't want to make people's lives more difficult, we are, of course, hiring. And if you want to make money move better around the world without ripping people off, come and have a chat with us afterwards or visit the website. And that's everything. Now, so questions, please.